is Jonathan Hall, and today I'll be explaining number 11 of the math final. The adjacent figure shows a cylinder circumscribed about a cube. If the edge of the cube is 3 inches long, find the volume and the total area of the cylinder. First, I found the necessary equations for this problem, which is the volume of the cylinder and the total area of the cylinder, but we'll get to that later. Next, I looked at the diagram from an aerial point of view, and I saw that the corners of the square were touching the circle at a certain point, which makes it a radius. So then I drew two radii, and I split the square into two triangles. And since if one side of the square is 3, the rest are 3. So then that shows that it's an isosceles triangle. And isosceles triangles can also be 45, 45, 90 degree triangles, which is what I wrote. And so down here, I wrote down two 45, 45, 90 degree triangles. And this is the problem triangle, which is referring to the problem. And this is the example triangle referring to 1, 1, and square root of 2 triangle. So then I use SOHCAHTOA and I use SO, which is sine of 45 is equal to opposite over adjacent, which is 3 over d. And then I use sine of 45 is equal to 1 over square root of 2. And since the sine of 45 is also equal to 1 over square root of 2, I can substitute that into this right here. And so I did, and I got 1 over square root of 2 is equal to 3 over d. And I cross multiplied, and I got diameter is equal to 3 square roots of 2. But I don't need diameter. What I need is radius. So then I use this equation to solve for radius. And so the equation reads 1/2 times 3 square roots of 2 over 1. And I multiplied that out, and I got 3 square roots of 2 divided by 2. That's one part of the volume equation. The next is height. And what that is 3. Because, again, with a square, if one side of the cube is 3, the rest are 3. So with this new information, I substituted it into the volume equation. And I got pi times 3 square roots of 2 divided by 2 to the second power times 3. And I distributed the square into 3 square roots of 2 into, and I got 9 times 2 divided by 4. And since these two can cross or reduce each other, the 4 becomes a 2 and the 2 becomes a 1. And that leaves me with 9 divided by 2. So then I put the 3 over 1 and multiplied it with 9 over 2, and I got 27 divided by 2 times pi. Now I wrote it this way, but you can leave it as this way if you want, but this just helps me. Now we're done with the first part of the problem. The next part is to find the total area. And what that is the area of the circle, which is this circle right here, and the area of another circle, which is this one down here as well. And then the area of the middle cylinder, which is this middle part right in here. So with the radius and the height, I substituted into the equation. And this part and this part are very similar to the volume of the cylinder. So I just went back and I looked at and look what I got for that, and I scribbled it down right here. And then, but for this part, I did 2 pi over 1 times 9 square roots of 2 over 2. And how I got that was put 3 over 1 and multiplied 3 square roots of 2 divided by 2 times 3 over 1. So then back to this. I multiplied this fraction with this fraction, and I got 9 pi square roots of 2. And then over here, I multiplied or added these two, and I got 18 pi divided by 2. And since 18 can be divided by 2, I divided it, and I got 9 pi. Then I brought down this, and I got plus 9 pi square root of 2. So then the final or total area should be 9 pi plus 9 pi square roots of 2. And that's how you do number 11 for the math final.